Explorer sending back unnerving information to Earth. The Explorer 1, NASA's farthest voyaged space apparatus, is as yet voyaging across unseen areas of the universe almost 50 years after its send-off. Researchers are astounded by the frightening information that this renowned space test machine is sending back to Earth because of what has all the earmarks of being a glitch. Join us as we discuss the odd information that the Explorer has been communicating back to Earth during its sensitive space investigation. Venture researchers have been intrigued in becoming familiar with the domain's past since the enormous detonation, and that is what roused the send-off of the Explorer 1 and Explorer 2 among other space missions. The Explorer 2 was really the first space apparatus to send off, departing from the NASA Kennedy Space Center on August 21, 1977. On September 5 that very year, Explorer 1 was sent off about 14 days after the fact. Anyway, how could they switch places as twins? The heaviness of the two tests is 720 kilos, roughly equivalent to a little vehicle. The two of them were sent off during a window of interesting out-of-planet arrangements that causes a slingshot impact to send off the shuttle from one planet to another. They have, however, had to move at different paces and on directions. On December 15, 1977, the Explorer 1 had the option to pass its indistinguishable twin. Along these lines, and since it has been our go-to asset for finding out about different realities in space-related puzzles, the principal shuttle to do so was this one, when it started its Jovian imaging mission in 1978. It was around 265 million kilometers from our planet and sent a huge measure of photos back to us. The Explorer 1 finished an exceptional 100-hour stretch starting in January 1979, during which it caught 3,750 pictures of Jupiter's revolution to produce a time-lapse film showing 10 of the planet's turns. It had gone through the Jovian Moon framework in February 1979, and after a month it had seen as the little ring surrounding Jupiter. Explorer 1 likewise made a unique revelation when it found two new moons named Hoodlums and M. Corrective moves would be made to guarantee that the shuttle is prepared for its flyby of Saturn and to forestall a likely impact with Titan, one of Saturn's moons. Explorer 1 additionally found 4 different moons during its circle of Saturn, including Mimas, Enceladus, Tethys, and Dione. Our researchers chose to stop the Explorer planetary mission after the Saturn mission was finished and sent both Explorer 1 and Explorer 2 beyond our planetary group at a speed of 325 million meters each year. In January 1990, the new mission, authoritatively known as the Explorer Interstellar Mission, began off some of the most popular photograph photos in history. Portraying the Sun and the greater part of the planets were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are habitually alluded to as the sunlight-based framework family photograph. There were 60 aggregate shots taken by Explorer 1, bringing the complete number of photographs taken by the shuttle to 670. In spite of the way that Mercury and Mars shouldn't be visible in the photographs because of multiple factors, eventually the rocket's cameras were stopped to preserve power and memory before its outing to interstellar space. Moreover, to the interstellar tests Explorer 1 and Explorer 2, NASA additionally works the Trailblazer 10, Trailblazer 11, and New Skyline rocket. Before Explorer 1 passing by the Trailblazer 10 on February 17, 1998, the Trailblazer 10 was the furthest rocket. Explorer 1 proceeded with its excursion for a further 14 years before it at last showed up in the interstellar climate on August 25, 2012, with no other space tests in sight to find. In any case, NASA didn't freely declare the achievement until 2013. How about we go to November of 2018? Both space tests have authoritatively left the planetary group when Explorer 2 crossed the heliopause and entered the interstellar medium. Explorer 1 is remembered to be 145 billion meters or 1,550 from Earth. It has kept on giving us with significant data that no other space test missions have been ready to unveil since it entered the unseen domain past our sunlight-based framework. The spaceship has spent the larger part of its 45-year trip in space in great well-being. Anyway, as of late, specialists have discovered a few odd irregularities in its exhibition. Explorer 1 is presently communicating mysterious signs back to Earth, giving the feeling that it is uncertain of its area. Coordinates there, however, is an unnerving turn to the issue. Ordinarily, researchers have pre-customized Explorer to go into experimental mode or sound an alert into the occasion that it becomes lost in space. Yet, up until this point, it has also its radio wire, which communicates information back to Earth, appears to be in extraordinary working request. Anyway, the information it has as of late been sending is dubious. The interstellar pioneer is working consistently, taking directions from Earth and conveying them out, as well as gathering and communicating logical information. Anyway, readouts from the test's explanation and control framework don't precisely reflect what is occurring inside, as per a NASA official explanation. What precisely is occurring on board? Then, each rocket that is going towards Barry Stell space, including the Explorer 1 and 2, has an extraordinary 12-in diameter gold-plated circle that is stacked with sound and video messages as a reinforcement in case an outsider species finds the boat. 35 Earth clamors, 115 live photographs, 90 minutes of Western music, and good tidings from previous U.S. President Jimmy Carter and previous Undersecretary General Kurt Waldheim are only a couple of the items on the space DVD. Moreover, they are kept in 55 unique dialects, so if it was taken over by outsiders, they would, apparently, be endeavoring to disentangle the signal. Contemplations that the spaceship is at present under the direction of outsiders have been immediately invalidated by researchers. Explorer's capacity to work depends intensely on the demonstration demeanor and enunciation control instrument. For starters, it generally keeps up with its receiving wire focused on Earth, so researchers can accurately get information. Furthermore, it controls how the spaceship is situated. Engineers watching out for the circumstance presently feel that the hatchet is working as it should, which simply adds to the riddle we as of now face. Also, none of the security highlights intended to protect the space apparatus from peril have been enacted. By Susan Project Supervisor for Explorer 1, and, to a secret like this, it's standard for the course right now. In the Explorer Mission Talk GPT, the space apparatus is both around 45 years of age, which is a lot more established than what was conceived in the mission plan, Sun, and, additionally, acknowledges that the shuttle's designing team will experience a few significant challenges in settling the issue with Explorer 1, due to the distance between us and the space test. The difficulties are considerable generally because of the shuttles being around 145 billion miles away from Earth. This tremendous distance presents a few difficulties that the group should explore cautiously. A salvage activity is almost implausible, conceivable, given the current innovation. Furthermore, the logistical imperatives Explorer 1 is a long ways past the range of any shuttle or fixed mission. That we could plausibly send the shuttle's inconceivable excursion has brought it into the peripheral regions of our close planet group. Furthermore, beyond into interstellar space, where it keeps on voyaging further away from us. Everyday message received from Earth at the speed of light take only about 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team demands a lot of investment to be received by the space. Voyager one-way communications back perhaps even started apparatus. This delay poses a significant challenge for real-time troubleshooting and exploring. Moreover, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This implies that two-way communication between Earth and the space apparatus takes an average of 2 days. Such a delay makes it particularly difficult to execute timely fixes or iterative troubleshooting processes, which are often crucial when dealing with complex technical issues. The engineering team must meticulously plan and execute each command, anticipating different scenarios and likely outcomes. Unlike missions closer to Earth where engineers can quickly send and receive orders, the long communication delay requires a more strategic and patient approach. Every instruction must be carefully crafted to address the known issues without causing additional problems. Considering the extensive time it will take to confirm whether the order had the desired effect, the critical communication delay also means that the engineering team has limited opportunities to interact with the space apparatus. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of orders on Earth before they are transmitted to Explorer 1. Despite these tactical challenges, the rocket itself is more than 40 years old, having been sent off in 1977. The technology on board, though state-of-the-art at the time, is now considered outdated by modern standards. The engineering team must work with equipment and systems that were designed and built during the 1970s, which adds another layer of complexity to the troubleshooting process. The harsh environment of space also takes its toll on the rocket systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its parts, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains committed to resolving the current ISS issues. They are exploring various hypotheses about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, deliberate approach is essential given the stakes involved. Any incorrect command could potentially disrupt what is happening or lead to a loss of communication with the rocket. The team is also utilizing the redundancy built into Explorer 1 systems. Like many space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team might be able to switch to these backup systems or reconfigure existing components to bypass the problematic parts. NASA said in another statement that until the cause of the problem is better understood, the team cannot predict how long the space apparatus will be able to gather and send science data. Regardless, Susan D. and the engineering team are confident that the problem will be solved if it's something that can be fixed with the A which controls the rocket's direction and articulation. It would still make it difficult to accept there was what was happening. GPT Explorer 1, NASA's farthest traveled rocket, continues its journey through unknown vast regions almost 50 years after its send-off. The data it now sends back to Earth is causing concern among researchers who are baffled by what appears to be abnormalities, perhaps due to breakdowns. This famous space test, along with its twin Explorer 2, was sent off during a unique planetary arrangement window in 1977. The two tests, each weighing around 720 kilograms, were propelled using a slingshot effect from one planet to another, exploring the outer reaches of our local planet group and beyond. Explorer 1 initially surpassed its twin by passing through the Jovian system in 1979, capturing stunning images of Jupiter and its moons. It later encountered Saturn, finding new moons and revealing the complex details of Saturn's rings. After completing its primary mission during the 1980s, both Explorer tests were redirected toward interstellar space, Explorer 1 in particular achieving this milestone in 2012, becoming the first human-made object to enter this vast unexplored domain beyond our solar system. Despite its age and the harsh conditions of space, Explorer 1 continues to operate surprisingly well. However, recent signals from the space apparatus suggest unusual behavior. Engineers monitoring Explorer systems have noted discrepancies in its attitude and articulation control mechanisms, which manage its orientation and antenna direction toward Earth. While the spacecraft systems appear functional, disparities in telemetry data and control systems have raised questions about its operational status. Engineers are carefully analyzing these anomalies, conducting simulations and tests on Earth to investigate and potentially correct the issues. The significant challenge of maintaining communication with Explorer 1 highlights the complexities of deep space exploration. Sending and receiving data from a space probe that is over 21 hours away in terms of round-trip communication time requires patience, precision, and strategic planning. Despite these challenges, the Explorer mission remains a testament to human curiosity, persistence, and the quest for knowledge. As Explorer 1 continues its solitary journey into the universe, it serves as an enduring symbol of humanity's exploration spirit, inspiring future generations of explorers and pushing the boundaries of what is possible in space exploration. The ongoing mission of Explorer 1, NASA's farthest traveled spacecraft launched in 1977, continues to intrigue and challenge scientists and engineers alike, almost 5 decades after its initial send-off into the depths of space. Originally designed for a primary mission that included flybys of Jupiter and Saturn, Explorer 1 far surpassed its original objectives, delving into the outer reaches of our local planetary group and eventually venturing into interstellar space. The spacecraft, weighing approximately 720 kilograms, was propelled using a slingshot effect, utilizing unique planetary alignments to maximize its speed and trajectory across vast distances. Alongside its twin, Explorer 2, launched during the same celestial window in 1977, Explorer 1 embarked on a journey that would redefine our understanding of outer space. During its early missions, Explorer 1 captured unprecedented images and data from the Jovian system in 1979, providing detailed insights into Jupiter and its diverse moons. This initial success set the stage for further exploration as the spacecraft continued its odyssey towards Saturn, where it discovered new moons and contributed significantly to our knowledge of the planet's complex ring system. As the 1980s unfolded, both Explorer probes were repurposed to explore the outer edges of our solar system and beyond. Explorer 1 achieved a historic milestone in 2012 when it became the first human-made object to cross into interstellar space, beyond the influence of the Sun's magnetic field. This achievement marked a triumph of human ingenuity and engineering, showcasing the durability and resilience of the spacecraft systems built with 1970s technology.